Hello and welcome to the YouTube channel D Creations Resources. We are looking at multiple choice questions from physics and maths. Today let us tackle a question from electronics. It is about the electronic device transistor, and this question is from the question paper of JEST, and it is from the year 2016. The question is, a transistor in common base configuration has ratio of collector current to emitter current denoted as beta and ratio of collector to base current alpha, and then which of the following is true? There are four options. Option A, beta is equal to alpha upon alpha plus 1. Option B, beta is equal to alpha plus 1 upon alpha. Option C, beta is equal to alpha upon alpha minus 1. And option D, beta is equal to alpha minus 1 upon alpha. Now, if you know the answer, you can pause the video, mark your answer and then cross check it. If you don't know the answer, just proceed further as it is. Now, it's a simple question, and how to proceed with this question? When you look at the options, you realize that basically it is going to be something to do with the definition that is in the question. So in the question directly they have informed you the definitions in terms of ratios. For example, it is told that beta denotes the ratio of collector current to emitter current. Now here I am assuming that you are aware of bipolar junction transistor and that it has three terminals: collector, emitter and base. And here we are talking about the currents corresponding to these terminals. So when you say ratio of collector current to emitter current, it is IC upon IE. This ratio is beta. Ratio of collector to base current, that means IC upon IB, which is alpha. So let's keep that in mind and solve it. So the options give you hint that you have to write these ratios. There must be some common relation between them, so write it down and then do a little bit of algebra and then you will reach the answer. So let us do it. We basically know that IE, emitter current, is sum of collector current and base current. That means IE is equal to IC plus IB. Now if you divide the entire equation by IC, what you get is IE upon IC is equal to 1 plus IB upon IC. But already it has been defined that the ratio of collector current to emitter current is beta. So IC upon IE is defined to be beta. So here IE upon IC is basically 1 upon beta. Similarly, IB upon IC is the next ratio, and we know that ratio of collector to base current, that means IC upon IB is alpha. So we basically taking its reciprocal. So 1 upon beta is equal to 1 plus 1 upon alpha. And once you reach this step, it's just a piece of cake, I would say. See, all you need to now do is rearrange the terms. So here you can just solve it and write it as alpha plus 1 upon alpha. And so when you are taking its reciprocal, beta is going to be alpha upon alpha plus 1. That's simple. And in the options, if you check, option A is the one which tells you that beta is equal to alpha upon alpha plus 1. So the answer here is option A. Thank you.